So we're busy with spider diagrams, and we're going to use these diagrams to apply our functions. Okay, so we know that everything on the left hand side is our input and our variable x. Everything in the middle is our function, and everything on the right hand side is our variable y, and also known as our output. Okay, so we see that our function over here is y is equal to 3x minus 4. So wherever I see x, I'm going to sub that in over here. So for number 1, I have y is equal to 3 multiplied by 5, because I'm using my 5 wherever my x was, minus 4. Then 3 multiplied by 5 is 15 minus 4, and 15 minus 4 is equal to 11. Okay, so I'm going to fill in that 11 over there for y. Then with my next one, with 8, I'm going to sub in 8 over there for x. So I have 3 multiplied by 8 minus 4. 3 multiplied by 8 is 24 minus 4. 24 minus 4 is equal to 20. Okay, so over here my output, when 8 is my input, I get 20. Then for my last one, I'm given my output y as 26. So now I'm going to sub in 26 wherever I have y, and then solve for my unknown x. So I'll have 26 is equal to 3x minus 4. Okay, now remember, we're going to need to isolate our x this time around. So I'm going to take my minus 4 over, and it will now become 26 plus 4 is equal to 3x. 26 plus 4 is equal to 30. And now I have 3x on the side, and remember, we just want x by itself. As this is 3 multiplied by x, we now need to divide both sides by 3 so that we can isolate our x. Okay, 30 divided by 3 leaves me with 10 on the side, which is equal to x. Okay, and I have now solved for my first function over there. Then moving on to our second one over here, they give us our inputs x and our outputs y, and we now need to decipher what is our function in the middle. Okay, so the way in which we go about doing this is we look at our x and we say, what happens in the middle over here for us to get our eventual answer y? So to go from 2 to minus 1, we see that there is a difference of negative 3. Okay, then we look at our second one, 4, and our output being y. There's once again a difference of negative 3. Then our last one over here, if we're looking at 6 and 3, once again we see there's a difference of negative 3. So for our function, we're going to say y, which is our answer, is equal to x, our input, minus 3. Okay, and you'll see if we substitute these values in here, we'll end up with our answers once again. So if I say my x is 2, then it will be y is equal to 2 minus 3, which is equal to negative 1. Okay. Next, we are going to be busy with our two-way tables. Okay, just an important thing to note, you will realize that we are working with an x and a y. Later on, you will be using these guys as coordinates, okay, and they are also called ordered pairs. So basically, like let's say our answer here was 4, okay, then our ordered pair would be 1 and 4, and that would be a coordinate on your function when you are going to be drawing our graphs and etc. at the later stage. Okay, but let's focus once again on our two-way tables. So you see that our function given over here is 4x minus 7, and in our two-way table we are given all our x values. So we are going to sub in our x values over there and then write our y values in the bottom section over there. So 4x minus 7, if I sub in 1, I have 4 multiplied by 1 minus 7, which is 4 minus 7, which then gives me negative 3. Okay, then with my second one, I will have 2 where I have x, so 4 multiplied by 2, which gives me 8. 8 minus 7 leaves me with 1. Okay, next one over there, I have 3. 4 multiplied by 3 gives me 12. 12 minus 7 gives me 5 over there. Then looking at our next one with 4, we have 4 multiplied by 4, which gives me 16. 16 minus 7 then gives me 9. And our last one over here, we have x being 5. So we'll say 4 multiplied by 5, which gives me 20. And then 20 minus 7 gives me 13 over there. Okay, if we move on over to our second example over here, you'll see that they give us some of our x values and some of our y values. So similarly with our spider diagrams, we just substituted our y values into our y in our equation and we work backwards to find our x. We will be doing the same thing over here with our two-way tables. So with x being 2, I'm going to say 2 multiplied by 2, which gives me 4. 4 plus 6 gives me 10 over there. Then with 4, I'll say 2 multiplied by 4 gives me 8, and 8 plus 6 gives me 14. Whenever they give you the y value, it is better to substitute into our equation, because that way we'll know we'll definitely get the right answer. Okay, so let's say y is equal to 2x plus 26 wherever I had y. So 26 is equal to 2x plus 6, and I'm now going to take that plus 6 over, and it will now be 26 minus 6 is equal to 2x. Okay, 26 minus 6 is equal to 20, and as we have 2 multiplied by x, we are going to divide both sides by 2, and we will be left with 20 divided by 2, which is 10, and over here just with x. So our input value that gives us 26 is 10 in that one over there. Then with 30, we'll put 30 where we have y, and then keep this 2x plus 6. Same procedure, take the 6 over. 30 minus 6 is equal to 2x. 30 minus 6 we know is 24. Once again, we have 2 multiplied by x, so we'll be dividing both sides by 2, and 24 divided by 2 leaves us with 12, and this stays x. So our input value that gives us 30 as an output is 12. Okay, then looking at our final one, we have y being 36. So once again, I'm subbing in 36 wherever I had y in my equation. So 36 is equal to 2x plus 6. And now I once again need to isolate my x. So I'm taking my plus 6 over, and that becomes minus 6. 36 minus 6 is equal to 2x. We know that 36 minus 6 leaves us with 30 on the left hand side is equal to 2x. And now that I have 30 is equal to 2x, I just divide both sides by 2 so that I can isolate my x over here. 30 divided by 2 leaves me with 15, and on the right hand side I'm just left with x. So for the last one, the input value 15 gives me my 36, and that is two-way tables. Thanks guys.